you can start.
So can you see my screen?
Yes, yes, visible.
Hello?
One second. Yes, visible, visible now.
Okay.
Can you make it as full screen? Yes. Okay.
You can see now, sir?
Yes, yes, yeah. Carry on.
Yeah. Good evening, everyone. Myself Shivani. Today I'm going to give a presentation on multiplexer topic. So basically, multiplexer is a combinational circuit that has two power n input lines and a single output line, in which two power n are the input lines, where n is the number of select lines. So in this multiplexer, it depends on the select lines. Whatever the inputs that you are giving as a select line, the 2 power n input lines will be taken as an output. This is also called as a data selector, as it has 2 power n lines and it select only a single data which is given to the output. So coming to example, if you like a system is being connected to various devices like printer, fax machine, ink color printer, and pen plotter as shown here. So here A and B are the select lines. So when you give an input of 0, 0, it will be going to the printer, and whatever the input is given from the system, that will be printed through the select lines. And this is the basic block diagram of a multiplier. As said, 2 power n input data lines, n selections, and a single output line. Coming to the types of multiplexers, we basically have four that we discussed: 2 cross 1, 4 cross 1, 8 cross 1, and 16 cross 1. 2 cross 1 is like it has two input lines. So since the 2 power is equal to 2, those selection lines will be 1. Similarly, for 2 power 4 cross 1, it will have a 4 selection lines and 4 input lines and 2 selections lines. Similarly, for 8 cross 1, it will have 8 inputs and 3 selection lines. Similarly, for 16, you will have 16 input lines and 4 selection lines. So depending on the selection lines, the input will be taken to the output. So coming to the first type, that is 2 cross 1. This is the basic block diagram of a 2 cross 1 multiplexer, where A1 and A0 are the inputs and S is the selector line. So here S can be either 0 or 1. So depending on the input of the select line, if 0 is given, A0 is taken as an output, and if A1 is if S is equals to 1, then A1 is given to the output. And this is the basic logic diagram of the 2 cross 1 multiplexer that we have seen before. So the truth table is as follows. As I said, if S naught is given 0, A naught will be an output, and if S naught is equal to 1, A1 will be the output. So the overall logic expression will be S naught bar into A naught plus S naught into A1. Similarly, focus 1 is also done in the same procedure. S1 and S naught are the two selection lines. So here we will have four combinations. Those are 0, 0, 0, 1, 1, 0, and 1, 1. Similarly, according to this, the binary code index, whatever it is there, it will be given to the output. And this is the logical expression for the output. And 8 cross 1. So here basically in all you will be having an enable, where enable is nothing but it is a switch which tells like if it is given 0, whatever may be the input, the output will be 0. So when enable states to 1, that is when it is in active only, then only inputs will be taken to the output. And this is the truth table of 8 cross 1. As said, 8 8 samples of S2, S1, and S0 you will be having, and according to that, outputs output will have the given input. And coming to implement how to implement a higher order multiplexer using lower order multiplexer, we have basically three steps. The step one is like how you have to calculate how many number of multiplexers are required in order to implement the higher order multiplexer. So what you do is, if we wanted to implement 4 cross 1 using 2 cross 1, so the lower order will be 2 and higher order will be 4. So you divide 4 with 2 and you get 2. So you have to divide with the lower until you get 1 in your output. And the first one will be a stage 1, stage 2, stage 3, and similarly it will continue until you get 1. Example that I have given is 8 cross 1 multiplexer using 4 cross 1 and 2 cross 1. So basically for 8 cross 1, the lower is 4. So first you divide 8 with 4, you get 2, which means you will use two 4 cross 1 multiplexers. And next you have 4. The output will be like 8 divided by 4 will give you 2. Then 2 you need to divide it with another 2. So you'll have a 2 cross 2 multiplexer that will be with 1. As shown, I have given the stages here. So this will be the logic diagram of the 8 cross 1 multiplexer using 4 cross 1 and 2 cross 1. And this is the truth table. So basically for this, as 8 cross 1 indicates, it has 2 power n inputs line, that is equal to 8, and n will be 3. So the three select lines are S0, S1 and S2. So the outputs of two 4 cross 1 are given as an input for 2 cross 1, and S1 and S0 are given as a select line for 4 cross 1, and S2 is given as a select line for 2 cross 1. Similarly, the gates also can be implemented using MUX. So NOT gate, as it is being used by 2 cross 1, where X is a signal select line, and as you know, the truth table of NOT gate is, if you give an input of 0, you get 1, 1, you get a 0. So this is nothing but complement of an input. So this I naught will be 0, I1 will be 1. So if X is given 0, you will take 1 as an output, and if X is equals to 1, you get 0 as an output. Similarly for AND gate, so depending on the truth table and the expression of your F, you can similarly write the
దానికి కనెక్ట్
inputs
అయినట్టుంది చూడు
and you
ఒకసారి.
get an output. The NOR gate, XOR gate, and NAND and OR are also given in the same way. So the problem one is a full adder that I have done using multiplexer. So for full adder, you have three inputs, that is A, B, C in, and for outputs you get sum and C out, that is carry out. This will be a carry in. So you draw the truth table of the full adder, then you get you can take the minterms of sum as well as minterms of C out. There you have to design the table of sum and C out. So after you get the expression for sum and C out, you can design you can design a 4 cross 1 multiplexer
మెల్లగా
using
కింద
the
వాడు.
outputs. So this is a design table wherein A is given as an input. As said, it is a sorry. As you can see that this is a eight like variable ones. So you will have it as A bar and then A. You will get an output. According to those outputs, you can design the multiplexer.
ఓకే, 1 సెకండ్.
These are the other two problems that I have seen. So coming to the first one, it can be directly implemented using 8 cross 1 multiplexer, wherein the outputs are 1 for 2, 3, 6, and 7 minterms. So actually, Hello, sir.
Yes, yes. Tell me. Yes.
Actually, I have forgot to put the solutions for that. Uh,
Okay, 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 okay.